So basically, I'm importing tkitter. Not sure why I'm importing it twice, but for some reason I am. Won't mess with it. I'm importing math because I got to do a little bit of math work, and time because I'm going to have the delays. So this very much uses the notion of object orientation. So we talked about object orientation in this class yet? Have we? Let me rehearse. There's a notion of a class, which is kind of a template. So for example, we're going to use, let's go through this first example. We have a class called a unit. So a unit is a military force, okay? It has various properties. And what we have here in Python, the way you create an object of class unit is you have to use a constructor. And the constructor you use is 2 underscores init, 2 underscores, and this has to be the one under unit. So if I invoke this and the way I invoke it is by saying unit with these parameters, actually without the self parameter, then I will construct a unit. So what kind of parameters does my unit have? It has a nationality, which is either red or blue right now. Those are the 2 nationalities. The unit has a name, and I have a naming convention for the unit. It has a type of unit. So the kinds of unit I have right now are infantry, cavalry, armor, and artillery. Okay? It has an X and a Y coordinate. So it exists somewhere on that board. Okay? It has a population, which initially is 1,000. There's a notion of fortification, which I'll get into later, but initially the fortification level is 1. Okay? You can think of this as producing bunkers and digging trenches, things like that. So 1 is the lowest level of fortification, essentially unfortified. And we have something called orders, which I will get to. Orders is another class, and I'll get into it. So you can think of what a unit is, that it has all these properties, okay? So the class unit just names the properties and maybe gives them initial values in some cases. But the object, there will be a bunch of units, unit objects, each of which will have their own copy of these properties. Okay? So I have a print unit method, and then there's a move method. So, all right, well notice that all the methods of a class have the word self in it. So self simply says that's the object that I'm referring to. When I call it...
So self is it special that you can't use it?
It is really a reserved word, yes. So for example, if I want to say, okay, the way I construct the unit, I might say, whatever, first arty, that's the name of the unit. But that's a variable. I can't begin with, well, let's just give an arbitrary name. Just gonna call it U for unit. So unit equals unit, and I've got to specify all the parameters except self. So it's going to be red, okay, the name of the unit, let's say, is 1 arty, first artillery. Unit. It's got a type, so we'll call that arty. And it's got initial X and Y coordinate, whatever that is, 0, 7 or something. And eventually it's going to have orders, so let's just say null for orders for the moment. Okay? So that's how I construct a unit. So the unit's name is U. by the way, I have to distinguish between the variable that points to the unit, which is U, and the internal name of the unit, which is first target. Okay? All right. So I have another method, which is move. So move applies. I could say u.move. And now I would have to give the target x and target y. So I might say 15, 16, or something like that. So that says this unit u is going to move to 15, 16. So now let's see what that looks like. Okay? So the first thing it does is it calculates the distance between its current position and its target position. Okay? All right. Fairly complicated expression for calculating its speed. Speed is a function of two things. It's a function of the terrain it's traveling over. So if you're on a road, you're going at maximum speed. If you're in the mountains, you're slowed down a lot. Okay? Second thing is what kind of unit are you? If you're an infantry unit, you're walking and you're fairly slow. If you're a cavalry unit, you're riding, you're faster. Okay? Turns out artillery units are actually the slowest units because they got a lot of junk to carry. Okay? So basically move this, this determines the speed in the x and y direction. I won't let you go off the edge of the map. So if you try to go off the edge of the map, I'll stick you at the last corner of the map. And if you haven't moved at all, I'm going to increment your... Okay, you have moved, but you're no longer fortified. You're at the lowest fortification level. In other words, once you've moved, you don't arrive at and have trenches and bunkers. You're out in the open after a move, or as you're moving. Okay, so that's the move method. Notice that it applies to a unit. Similarly, we have a fire method. So self refers to the unit doing the firing. Target unit is another unit, presumably on the other side. Let's take a look at what I'm doing. First of all, I have to calculate the distance between me and the target unit. Okay, I'm not going to let you fire on your own people. Okay, if you're the same nationality, I'm not going to let you fire. Unfortunately, in real war, that does happen sometimes, but not in this game. All right. Okay. Now, if my distance between me and my target is 0, I don't have to move anymore. Okay? And I am using up supplies, but I don't ever want my supplies to go negative. Okay? So if my supply ever tries to go negative, I'm going to set it equal to 0. Okay. The other thing is, as I'm firing, again, units start with 1,000 people. If it ever goes below 2, I'm going to stop firing. There's no point in firing anymore. Okay? Okay, firing effect is fairly complicated. Okay, so first of all, it depends on what kind of unit is doing the firing. The heaviest, the strongest effect of the firing unit is the artillery. Secondly, armored. Cavalry and infantry actually have the same firing levels. Cavalry moves faster, but doesn't fire any better than the infantry does. Okay, the other is, who am I firing at, and what is their fortification level? So basically, at a high fortification level, the firing is less effective. Also, if you're firing at an armored unit, your fire is less effective than if you're firing at an infantry or cavalry or artillery unit. Okay? There's one other factor, and that has to do with range. I think I'm doing fire effect. I'm I'm looking at my cursor on the screen, it's lagging behind here, so it's hard to. Alright, so let's look at fire effect. Okay, so it depends on the target unit type, it depends on the fortification level.
这个音乐打开，看不清楚。
不是，不是。
Okay. And so as I'm firing, I'm using up supplies. And all this is calculating the fire effect. So finally, my target unit is decremented by my firing effect. So that's, if I'm firing at a unit, it's taking losses. So that's the fire routine. There's the fortify routine. Basically, it just increments by one level, actually times the time interval. But I'll never go to a fortification level greater than 5. Okay, so status. Remember that display on the right that had population and supply? Is that what I'm doing? No, I'm not. I'm sorry. No, that's not what's going on. Remember the ID of the unit that's moving across the map? That's what's getting displayed here at status. Okay. Distance is pretty self-explanatory. Why is distance recursive? That's odd. Oh, I see. Okay. So one thing you can do is you can, in the world of object orientation, you can have several distinct definitions for a method with the same name. So I have two definitions of distance. How do I know which one to use? This one says I have a unit as a parameter. So if I want to know the distance between myself and another unit, I'm going to use this version. And what's it's doing? It's actually calling the other version. So this version says, oh, if I have an xy coordinate here and an xy coordinate here, it's going to calculate the distance. And when it does, it's going to use basically Pythagorean theorem to calculate the distance. So if I'm asking what's the distance between two units, it's going to look at the x and the y coordinate of myself and the x and the y coordinate of the unit I'm looking at, and it's going to call the other method to actually calculate the distance. Okay? Print OOB was mostly, OOBS by the way stands for order of battle, which is just a list of the units. That was mostly for debug purposes. And I've got a fire order, which is right now kind of a stub. All it's really doing is printing which unit I selected on my GUI. Ultimately, that will get a lot more complicated as I actually construct an order. And we'll talk about orders in a little while. Similarly, move order, all I'm really doing there is printing the string move order. Well, I'm still testing my GUI, basically. And so my GUI works. I'll show you a moment how that works. Okay, so we have one class, and so far we've been talking about the class unit. So that's a fundamental principle in this game. I have units and they do things, okay? Now, there's another class. And it's called unit type. So basically, I did not want to have to separately describe what a cavalry unit was every time I instantiate, I construct a cavalry unit. So I'm going to say a cavalry unit is of type cavalry, and I've described cavalry in one place, but that means cavalry itself is an object, and I have to define it. So I have a class called unit type. There's its constructor. What is OFF? Okay, we'll see how it's used in a moment. I've forgotten what these two variables are. But it has a speed and a range. So cavalry is faster than infantry, for example. And when they fire, artillery has a longer range than infantry. Their guns are more effective at even a longer distance. Okay, I'm going to display the unit type. Okay, I have another class called orders. So an order basically has a destination, it has a target, and instructions to fortify. So basically I can describe orders in this way. Again, I have a class orders. I'm going to basically say, I'm going to just give a pointer to orders to a particular unit so he knows what to do. Okay, and I have a display orders method, which is mostly for debug. Okay, another class is terrain type. So every square in our map has a terrain type. And it's got, first of all, color. When a unit is moving, it has a velocity. I would think of this as a factor because the unit type also comes into it. But basically, for example, on a road, that's the fastest velocity for a terrain type. I believe water is the slowest. My model for water is people have to row boats across the water, so they're going pretty slow. Okay, mountain is a little bit slower, plains are faster, forest is a little slower, but I have different sort of velocities associated with different kinds of terrain. Okay, and lastly I have cover. So basically if you're out in the open in a plain, you have no cover. But if you're in a forest, you have some cover. You can hide, fire is less effective on you. If you're in the mountains, I'm presuming there are rocks and things you can hide behind, and you have some cover. If you're on a road, you have no cover. If you're on a plane, you have no cover. If you're on the water, you have no cover. Okay? So the effectiveness of fire against you depends on what kind of terrain you're in. All right, so those are our classes. Any questions about what a class is? Okay, can you explain what a class is? What's the difference between a class and an object?
Object is like a
Okay,
Probably not.
all right. Do you want to explain it to him?
It's like a specific instance of a class. Like basically, you create an object based on that type of class.
Right. So we have a class called unit, for example, and I'm going to create various units. But they all share variables in the sense that they all have a name and a type, and they have orders and a position. The position belongs to a particular object. Each object can be in a different position. But the variable for x coordinate and y coordinate, that's a class property. The variable is a class property. Its value is an object property. Okay, so we've defined a bunch of classes. Now let's see how we're going to do it. We're going to instantiate them. I'm going to instantiate some terrain types. So I'm going to have 5 different terrain types. And you can see that I'm going to give a particular color to each terrain type. By the way, I named them plains, woods, hills, water, and roads. I could have other terrain types. But I choose to construct 5. I give them colors. And what's the other one? Terrain types. So what kind of velocity? So on a plane I can travel with a unit velocity. In woods, I can only travel half as fast. Presumably there's no roads, I gotta cut my way through the woods. In hills, I've got a quarter. It's hard climbing up and down hills. You can slow down. On water, I'm slowed down even more. I'm presuming I'm rowing in rafts or boats, going really slow. But on roads, I can go 3 times as fast because it's smooth, I can move. Okay? So those are my terrain types. Anything else I gotta do? Oh, I gotta describe the cover. So in plain, it's unit. In woods, effect, the 0.5 will be multiplied and become part of the fire effect. Hills, there's some cover. Water, there's no cover. On the road, there's no cover. Okay? All right, so I've defined all my objects of terrain type. Now I'm going to define orders. So this is kind of test data. In fact, I'm going to, later on when the game's a little further along, all my orders are going to come through the GUI. That's how I'm going to, but for test purposes, I wanted to see how an order worked. So I'm going to create an order for the blue, and basically what I'm saying is he should move to the 12-12 coordinate position and not do any firing and not doing any fortifying. Similarly, red is also going to go. So basically, and it turns out I will give all right. Those are my 2 orders. Think of those as mimeograph pieces of paper that I hand out to units, okay? Okay, I have various unit types. So infantry, cavalry, armor, and artillery. So this is their relative. First column is their offensive strength. Armor and artillery are stronger than infantry. Defensive strength, armor has high defensive strength. Everybody else has lower. Mobility is how fast they can move. So cavalry and armor can move 3 times as fast as infantry. Artillery is actually a little slower. And lastly, range. So I have unit range for the infantry and the cavalry, but armor can fire twice as far, and artillery can fire 4 times as far. All right, so now I'm actually constructing my units, and on each line I have 2 units, 1 red and 1 blue. So I'm gonna, here's all of my red units. I'm giving them a name: 1st Infantry, 2nd Infantry, 1st Cavalry, 1st Armor. Again, in principle, I can define as many units as I want. I'm just defining 5 at this point for each side. Same thing for the other one, but he's blue instead of red. I think everything, and I'm giving them an initial coordinate. So the blue, I think, is up on the upper left, and the red is mostly on the lower right. But I'm asking them all, my orders tell them, go to the center. Okay? And I am saying that the target for the blue orders are the 1st Infantry. Remember, this was a unit. So this is an object. So I'm saying his target is this object. And the order for the red is this. The first letter, by the way, tells you which nationality it is. So the blue army fires at a red target, the red army fires at a blue target. Okay, and I'm setting up 2 lists of units. All right, that's a lot of initialization. I've created all my objects now. You have some feel about the relation of what an object is to the template. Okay, so I'm going to, next thing I'm going to create a map. It's going to be a 25 by 25 map. My cell dimensions. Okay. What am I doing here? Anyway, I'm setting up a cell dimension which is related to my map dimension. I think this was some trial and error to set up the right size. All right. This is kind of an interesting idiom in Python. suppose you want to initialize a array or a matrix. So I'm going to initialize it with zeros. And I'm going to start with an array which just has a single zero in it. But the asterisk, when applied to an array in vanilla Python, I have to make that caveat because there's a very important library that we may or may not get to called NumPy, which is numerical Python, which reinterprets the asterisk to mean something totally different. But in vanilla Python, this means replicate that array element by the map dimension. Well, map dimension was 25. So what that's going to give me is an array of 25 zeros. Okay, but I'm going to do that for each I in the range map dimension. So basically what I'm going to do is this expression produce 25 zeros, but I'm going to do it 25 times. So I'm going to get a 25 by 25 array. Okay? That's kind of what the comment is saying. Construct a 2D array, matrix of zeros. So that's just my initial one. Now I'm going to march through that map, and I'm going to basically, you notice the stripe pattern in the map? It's an outcome of this expression right here. I basically have a number of different, and each of these, by the way, is an object, a terrain type. And I'm going to add I and j modulo 7, because I believe I have 7 types. No, 7 items on this list. 1, 2, 3, 4, 5, 6, 7. So basically I'm going to repeat in a pattern. And since 7 is not a proper divisor of 25, I'll get a kind of a stripe pattern. If it was, I'd get vertical pattern. Okay? So that's how I generate that. And then I, in a separate step, say if any of those things are true, I'm going to draw a road. I'm going to overlay that with a road. So basically I have 2 major intersections and then a couple of diagonal roads on the map. Okay, so remember our talk here. What is all this object orientation and this map array? How does that affect what we're doing here? What category does all that fall into?
View?
Not exactly. That's really the model. Okay? That's how internally I represent the state of my system. I have units, they have positions, I have terrain, they have characteristics, I have orders. All that represents the internal model of my system. So the next question is, how do I externalize that? How does the user see all that? That's the view. Okay? All right, so I think we're going to start doing that just about now. Any questions so far? Do you understand the concept that we have a model that represents the state of the system? Okay, so we're going to look at the view now. In many systems, by the way, one of the things I could have done, and I was thinking about doing that last night, is separating this into 3 different files. Right now it's all sitting in one file called Krieg 05. By the way, it's 05 because it's the 5th iteration of this piece of code. But I was thinking of dividing it into basically these 3 pieces. So all the class definitions I put in one place, or maybe 4 pieces. All the view code I put in another place, controller code I put in a 3rd file, and then I'd have to import them. Probably I'd have a 4th file, which is kind of an overall running the model file. Okay? And I'd use import statements to combine them all into one piece of executable code. All right. So I've set up my map. Okay, beginning about here. Yeah, I probably should have a big fat comment here. Okay. All right. I'm going to use tkitter tk What that does is creates a window.